Students, this is the lesson 6 video on interval notation. We're still in the inequalities unit. We just had a quiz, and now we're going to take a look at another way to represent intervals. Another way to represent inequalities, I should say, with intervals. For the lesson target for today, we're going to be expressing inequalities using interval notation. We're going to be talking about exactly what that means, and then converting between multiple representations of a solution set. So I might give you an inequality, I might give you a graph, or I might give you an interval, and you should be able to convert between all those three things. All right, for the do now, it says to graph the following compound inequality on the number lines provided. Here's the inequality. X is less than or equal to 9, and x is greater than 0. This and means it's going to be a convergent inequality, which means the lines are going to come together. Pause the video and then try it out, and then come back to see if you got it right. X is less than or equal to 9 means that there's a shaded in circle at 9. X is greater than 0 means it's an open circle at 0. We're shading in between there to represent the fact that all of the values in between 0 and 9, including 9 but not including 0, are valid solutions to this inequality. For example, 6. 6 is less than or equal to 9. That works. And 6 is also greater than 0, so that works as well. We're looking for values, all of the values really, that solve both inequalities. If I were to write a single inequality, that means I want to write the inequality so that all of the numbers and all of the variables are all together in one sentence. It's kind of like the example over here. In the remember section, it tells you to rearrange the inequality so that the x value is in the middle, then combine the inequalities at x to make sure the smaller number is on the left. So the smaller number is 0. So I'm going to rearrange this first. 0 is less than x. Remember, x is bigger than 0, which means x is the larger value here, which means if I put x on the right-hand side, the alligator still has to be eating the larger number, so 0 is less than x. I don't have to rearrange this. I'm just going to write it down just like it is, and we'll try to combine those into one inequality. Our combined compound inequality, we have 0 is less than x is less than or equal to 9. Smallest number on the left, largest number on the right. All right, moving on to interval notation. So an interval is a connected subset of numbers. All that means is an interval is a group of numbers in between like a lower value and an upper value. And it's connected, which means there's going to be a line between it. Interval notation is another way to express your answers in inequality. So I could write my inequality like this, or I could write my answer in an interval notation. So here's the example. The inequality here is 2 is less than or equal to x is less than 6. So on a graph, this less than or equal to would indicate we're supposed to use an open circle, a closed circle. So that symbol, which means x could be greater than 2 or x could be equal to 2, that symbol means 2 is included in the answer. If 2 is included in the answer and included in the solution set, I'm going to use this bracket, which is sometimes known as a square bracket or a hard bracket. That means included or closed circle. Now this symbol over here, less than with no equal to at the bottom, that means it's supposed to be an open circle. In other words, 6 is not part of the solution set. 6 is just a boundary. So since it's an open circle, since there's no equal sign here, we use the soft bracket, sometimes known as the parentheses. It means not included or open. So every time I see a less than or equal to, that kind of symbol here, I'm going to use a hard bracket. Every time I see one that doesn't have an equal to, I'm going to use a soft bracket. In other words, every time I see this, I'm going to use a square bracket. Every time I see this, I'm going to use parentheses. Okay, move on to the partner practice. I am going to show you the correct answers to the partner practice, but I do want you to try them first. So for each representation of a compound inequality, you're going to identify the interval notation. I'm actually, sorry, I misspoke here. I'm only going to show you the answers to A and C. You're going to try to do B and D by yourselves in class. Okay, so for -6 is less than x is less than 9, what does the interval notation look like? That the interval looks like this. Notice that in the interval, the x is not written. The x is implied here, like, oh, interval means the x value is going to be in between -6 and 9, not including 6, not including 9. Why are these both parentheses or soft brackets? Because there's no equal sign here, and there's no equal sign here, okay? So there's our interval notation. If we had had an equal to on one of these, then we would have used a hard bracket or a square bracket like this, but there's no equal to, there's no equal to, so we use the soft brackets. There's a hint for what you're supposed to do in class. That bracket over there is going to be a hard bracket. You might want to put that down in your notes. And then for letter C, I'm looking at a number line, and the number line has a closed circle here and an open circle at 1 and 5 respectively. What does that interval look like? Here's our interval. We have a square bracket at 1, we have a curved bracket or a parentheses, a soft bracket at 5, because 5 is not included and 1 is included. All right, notice that there's no x included in here because we're not writing it out as an inequality. When you're writing an interval, you don't have to write the x. As a matter of fact, it would be incorrect to write the x. All right, so like I said, B and D are going to be doing in class. Let's move on to the next page here. Go through these one at a time. The first one, it gives you an inequality first. Now you have to translate that inequality into a graph and an interval notation. Pause the video and try this one out, and then come back to see if you get it right. Do the graph first. This means closed circle, so we're going to put a closed circle at 3. This means open circle, so we're going to put an open circle at 7. X is in between those two numbers, so we're going to shade in between. And last, we're going to do interval notation. Remember, we don't need to use the x, but we're just going to take these same exact numbers and write them down here. Looks like this. That less than or equal to indicates closed circle, indicates hard bracket. That less than indicates open circle, indicates soft bracket. The more you try this, the more practice you get with this, the better you'll remember it. So hopefully you're practicing this by yourself at home. Let's take a look at this representation, which is a number line. We have an open circle at 1 and an open circle at 5. So let's write down the compound inequality first. Remember, when you're writing an inequality, the inequality does have to have the x in the middle there. Looks like we're shaded in between, that's why the x is in the middle, and 1 and 5 are the key numbers, so we're writing down 1 and 5. They're the ones that are circled. That's a good rule of thumb. They both have open circles, so we're using less than both times. Here's a good thing to remember. Whenever you're writing out a compound inequality for a graph, the smallest number is always going to be on the left, the largest number is always going to be on the right, x is in the middle, and these symbols will always, always, always be less than. It's got to be like that because we're writing it as this is the smallest number, 1. This is the largest number, 5. So x is going to be larger than 1, but smaller than 5. So the arrows have to go like that. 1 is less than x, which means x is greater than 1, and x is less than 5. Okay? Hopefully that makes sense. Take a look at the interval notation, which looks like this. Soft brackets because of 2 less than symbols because of 2 open circles. Sometimes folks get this confused with a point, like, x is 1, y is 5. However, if it says interval notation, if it's labeled as interval notation, you don't have to worry about that. It'll say, oh, this is interval notation, not a point that you're supposed to graph on a coordinate grid. Sometimes folks like to do this. X is 1, 5. It's not necessary. Sometimes you'll see that in textbooks, and sometimes you might see that on the Regents exam, but most often the interval notation will be clearly labeled as an interval. Speaking of interval notation, here's one example. 8 with a hard bracket, 11 with a soft. What does the graph look like? Well, I'll show you. Open circle at 8 because of this hard bracket, this included symbol, and then open circle at 11 because of that soft bracket, parentheses, not included. Let's take a look at the compound inequality, which is simply 8 is less than or equal to x is less than 11. Less than or equal to because of hard bracket, less than because of soft bracket. All right. For some reason, this is labeled as number 2, but trust me, it's number 4. Let's take a look at this one, which is x is in between -8 and -6, inclusive, right? Both of them are included. Here's what the graph looks like. Looks kind of like a dumbbell here, 2 filled in circles because of the less than or equal to and the less than or equal to here and here. The interval notation looks like this. Hard brackets, 2 square brackets because 2 less than or equal to symbols. Last but not least, we have question number 5. We have starting at 1, ending at 5, not including 1 and including 5. Here's the compound inequality. Went ahead and did the interval notation as well. Both of them are very similar. Open circle gives us less than and open parentheses. Closed circle gives us less than or equal to, and a square bracket, a hard bracket. All right, simple inequalities are actually very similar to compound inequalities, except instead of having a starting and an ending point, your starting or ending point will be something else. I'll show you in a second. It says to graph the following, so go ahead and graph these. Take a second, pause the video, and then come back to see if you graphed it correctly. Baby stuff here. X is greater than -3, so starting at -3, open circle, shaded upwards. X is less than or equal to 5, closed circle at 5, shading downwards. Now, if we want interval notation, remember, With any interval notation, we had a starting value and a stopping value, right? In these cases, we don't really have a starting or a stopping value. However, you could consider this starting at -3 and ending at positive infinity, right? If you kept going on along this arrow, until the end of time, that represents you're going on until infinity. And then same thing here, x is less than or equal to 5. We're starting at 5, that's the highest value, and the lowest value down here is going to be negative infinity, right? So if I were to express this inequality in interval notation, the smallest value here would be -3. Largest value up here, well, it would go up until infinity. In my interval notation, I'm going to start at -3, open circle, and going to infinity. We never really reach infinity, right? Infinity is the concept of an ongoing number, so we never really get there. So I'm not going to use a square bracket. I'm not saying that infinity is included because it's not really even a number. I'm going to say that we're putting a soft bracket at infinity because we never really get there. So here's the interval notation. There we go, starting at -3 with an open parentheses, ending at infinity with an open parentheses as well because you never really get there. Same thing here. My smallest value in the solution set here is negative infinity. Highest value is 5. I am including 5. So that goes here. So now if I was expressing the inequality in interval notation, I'd start at negative infinity and I'd go up to 5. I'm not including negative infinity because I never really get there, but 5 is a closed circle. I am including it, so that's going to have that hard bracket. All right, there we go. That's a simple inequality graphed as an interval. All right, moving on, there's the note that says that infinity and negative infinity, which you'll use for single inequalities, they always use parentheses in interval notation. We never use a square bracket when we're dealing with infinity on that side. For the solo spot, I'd like you to pause the video, and then I'm going to show you these correct answers. I'll just scroll through them so you can see, and then we'll do the problem set in class. So pause the video now, try these out, and then come back to see if you got them right. There we go. You should see square bracket every place you see a filled in circle or a less than or equal to. You should see an open circle every time you see a parentheses, soft bracket there. You should also see a infinity wherever you see an arrow, right? So this is going to negative infinity. This one's going to positive infinity. A common student error is to say that this is infinity, but if it's in the negatives, it should be negative infinity. All right, we have a couple more exercises down here. Take a look at E and F and then the Regents prep. I'll show you the correct answers for those right now. Right, this one was pretty straightforward. Open circle, closed circle, soft bracket, open bracket, or square bracket, I should say. And this one has an or. This is the only example in which we're trying to split these two apart. It's not an and inequality, it's an or inequality. This is very rare. They might not show you on the Regents, but if they do, x is less than -4, so that goes this way, or x is greater than or equal to 3. I'm reading it backwards so that I could actually graph it effectively. And then the interval notation means we have to have two intervals because there's one interval back here and one interval or solution set up here. The Regents prep is answer B. That's less than or equal to, which means a square bracket, a less than, which means an open bracket. All right, I'm not going to show you the multiple representations because that's what we're going to be doing in class as a problem set. But let's go back to the beginning and call it a day. This was the lesson number 6 on interval notation in the unit on inequalities. All right, folks, good luck studying.